Power we can simply define it is the rate of doing work. What is the rate of doing work? What is the meaning of rate of doing work? Well, in physics, when we write rate and the power is rate of doing work. So when we say rate of doing work means the power is divided by time. And we can say from this equation that power is directly proportional to the work and inversely proportional to the inverse of time. That means the more work we will do, the more power we are having, and more less time we will do a work, then more power we are having. So power we can say also the work done per unit time is known as power. Work done per unit time. We can say this power is work upon time. So work value we know it is joule and time is second. So power unit is joule per second. Or we can say instead of saying joule per second, we can say watt. So 1 watt is 1 joule per second. We'll come back to the unit later, but first of all, we need to understand the physical significance of the power. How we can actually imagine which one is more power and which one has the less power. So here we are having two cyclists. Suppose this is cyclist A and this is cyclist B. And suppose the cyclist is applying a force forward to move forward, and the cyclist move certain distance. Suppose the distance is s, okay, and she applied the force F. So the work done will be Fs. Okay, and suppose this cyclist applying the force of 20 Newton and produce a displacement of 10 meter. So we can say the total work done will be of 20 into 10. It will be 200 joule. But suppose she covered the distance within just 2 seconds. So power, how we can write power? Power is work upon time. So work she has done, which is almost 200 joule. So we'll write 200 joule. And she took 2 seconds to cover 10 meter. So I'll write 2. Now you can see the power is coming around 100 watt. Okay, in the case of B cyclist, she's covering the same distance of 10 meter, and she applied the same force of 20 Newton. She is having more power. Let's understand. So work done will be, in this case, will be also 200 joule, and the displacement we are having also over here 10 meter. Now suppose the time she took is just 1 second. So what will be the power in this case? So we can divide the work upon time, 200 joule upon 1 second. So it will be 200 watt. So what we have understood, even though both of them are applying the same force and producing same displacement and doing the same work, but B got more power just because she's doing work in less time. And that's what we call this. Power may be a directly proportional to the work, but power also inversely proportional to the time. So the less time, more work. More work, more power. Less time, more power. Hope you understood this. Now let's take the another example. Here's the two people are lifting some weight. Suppose both of them are lifting the same weight. So from the ground, they covered a distance of 10 meter, not just 10 meters, suppose 1 meter. So 10 meters is quite long. And both of them are both of them are carrying the weight also same, which is 20 kg. Okay, this one is also carrying the weight 20 kg. So he applied the force upward. He also applied the force upward and produced the displacement in the same direction. Okay, so what will be the force in this case? So force will be, it is mg equals to the mg, the weight of the this heavy weight. Okay, so the mass is 20 and acceleration we can take 10. So the force is obviously 200, and he covered 1 meter distance. So we can say that work done by this person A will be 200 into Fs. 200 into 1 meter. So this means 200 joule. Same goes with the B also. B person will apply the same amount of work. But suppose this boy is stronger, and this boy is also strong, but he's not as strong as comparison to this one. So who do you think that will lift the weight first? Obviously A. A will take less time and B will take more time. So whenever work done is same, so we can say those who are taking less time to do the work will have more power, and those who are taking more time to do the same work will have the less power. So both of them have this doing the same work, but the power of A will be more because he's taking just 1 second and he's taking 2 seconds or maybe more than that. So in this case, power will be inversely proportional to the time. Hope you're understanding this. Just power defines that you are doing the work, but how much time you're taking. So when we calculate work done on the basis of time, so we can say it is a power. We can take the another example to clarify the concept more deeply. Let's take two engine bike over here. Is this one is a bike A is having one engine and this one having two engine B. Suppose both of them traveling in a 1 second, okay, and this one also traveling in 1 second. But what happened? This bike traveling in 1 second just 10 meter. 10 meter it is traveling, and this bike is traveling 20 meter in 1 second. Who do you think will have the more power? Obviously, what we said earlier, that power is directly proportional to the work and inversely proportional to the time. So in this case, both of them are taking same time, but in the case of work, this bike B is doing more work because it's traveling more distance, and suppose it is applying certain force of 10 Newton, and this bike is also applying a force of 10 Newton. So in this case, what you're going to see, the work will be 10 force 10 Newton into 10 meter, and this will be 100 joule. This bike, in this case, applying the same force 10 Newton, but traveling the distance of 20 meter, and this will be 200 joule. So you can see this one, it is clearly we can say that the bike B has the more power than the bike A because it covers in the same time covers more distance comparison to A, and this happens, we see most of the bike having more cc, and it actually defines that how much distance it can cover within the same time the rest of the bike will take to cover. Hope you understood this. Let's talk about the power in the terms of energy. We're going to talk about the power in the terms of energy. Okay. The power in the case we write power is equals to work upon time. And we know from the work energy theorem that the work is nothing but change in energy. When we do work, there's the energy changes. So instead of writing work, we can write power is change in energy upon time. And that is how we call the energy transferred by a body is called power, because here the energy is changing, so we can say rate of, because we are dividing with the time, so we will use the rate. Remember, in the physics, whenever we are saying rate, that means we are dividing with the time. So when I'm dividing with the time, we can say rate of energy transfer, or we can say energy change is called power. So in the exam, if it is coming, suppose that there is a multiple choice questions are given. One is saying rate of doing work, another is saying rate of change of energy is also power. So both of them are correct. You have to remember there could be any definition regarding the power, and you have to actually understand from the mathematical point of view that the power is work upon time, and we know work is nothing but change in the energy upon time. So the rate of change of energy is also called power. Let's talk about the unit. Earlier we discussed that 1 watt is 1 joule per second. So how we can define the watt? How we can define 1 watt? So we can say that when 1 joule of work is done by a body in 1 second,